Alright, this is part 2 of the video of the review for MAT160 Exam 1. So we're going to pick up with question 2 in this review. So question 2 on your review is it's more of a calculator problem. So we want to approximate x to the third power minus 5x plus 3 equals 0. We want to approximate that. Well, we want to approximate the solutions, I should say. Approximate the solutions to this to 2 decimal places. Alright, that's what the instructions say. So I'll make a small coordinate system here. Right. So the solutions to this equation are going to be, where the equation crosses the x-axis. In other words, when it's equal to 0. Right. We also call the solutions the roots to the equation, or the zeros to the equation. They're all the same terminology. So remember, to do this in your calculator, just go to y equals, type in your equation, which we already did. So I'll type it in again. X to the third power minus 5x plus 3, and graph it. And there it is. So my window is adjusted from negative 10 to 10 in the x direction and negative 10 to 10 in the y direction. Sometimes you have to play around with that just to get the nicest possible view, but my graph looks something like this. So this is a polynomial equation, but our graph looks something like that. Alright, so we're trying to find these particular values. This one, and this one. We're trying to find the values where this equation equals 0. Well, those are the points where it crosses the x-axis. So there's 3 of them. So there's 3 solutions to this equation. So we're doing this in our calculator because this is a cubic equation, and there are no ways to solve this cubic equation by hand. You couldn't do it. You can't solve this cubic equation by hand. You couldn't factor it. Obviously, this is not a quadratic because this is to the third power. So I have to use my calculator. So to do that in your calculator, you're going to go to second trace to get to calculate. You're going to go down to number 2 to find the 0. Right? We're trying to find the zeros of this equation. The 0 is the point of x where the equation equals 0. So hit enter there. And what you're going to do is you're going to go to the left bound. So you're going to go to the left. So we're going to do each one. Right? I'm going to do this one first. So I want to pick a left bound. So that means I want to pick any value to the left. I want to pick any value to the left, or in other words, below where this 0 of the equation. So I want to pick any values to the left, right? Because if you look at it this way, it's to the left of that. So that one's good enough. Hit enter. Now you're going to go to the right. That's good enough there as well. You want to pick a value to the right or above it. That's good enough there. Hit enter, and then you're going to enter again to guess it. Boom. So there's the first 0 to the equation. So this x value right here is approximately, and we're going to round that to 2 decimal places, so it's negative 2.5 approximately. All right, now this one, second calc, go down to 0. A left bound, so I want to pick a point to the left, and then I want to pick a point to the right. This is to the left of that value. So, because we read this from left to right. So this is the left, this is the right. So just trace to get to the left of that 0. So right around there is fine. Then go below it to get to the right of it. That seems fine. Hit enter. So that x value is approximately 0.66. All right. And now the third one. So again, pick a value to the left, and then pick a value to the right. So you could calculate this as 0. Second, calc 0. To the left, that looks fine. Then go to the right, that looks fine. Boom. So 1.8. Because we're rounding into the 2 decimal places, so 1.8 is fine. So, or, well, I guess if it's 2 decimal places, it's technically the hundredths place, right? So, I mean, if you round it to the decimal, to the hundredths place, or to the 10th place, that's okay, but I suppose I could do a little bit better than that. Let me look at the first one again. So negative 2.49, or you could say that, that's fine. If I want to do this one again, left bound, right bound, 6.5. Actually, no, that one's perfectly fine. That one's fine, I don't need to worry about that one. Let me look at the third one. Yeah, so this one could be or 1.83. So either way, your solutions the solution set is going to be the value. So I always go from least to greatest. So negative 2.49, comma 0.66, comma 1.83. So those are my solutions to this equation using your calculator. Yeah, pretty straightforward. So number 3 is solving inequalities, right? So letter A. So you want to solve the following inequalities, and you want to express your solution set as interval notation or as an inequality. Okay, let's do that. So letter A is the inequality 2x minus 3 over 5 plus 2 is less than or equal to x over 2. Right? So whenever I have fractions here, right, I don't like fractions. Well, nobody likes fractions, right? We don't want to work with them, right? That's the point. We don't want to work with fractions. So how can I get rid of these fractions? Well, if you recall, you could get rid of these fractions by finding the least common multiple of the denominators, right? So if I find the least common multiple of 5 and 2, it's going to be 10, right? So what I could do is I can multiply both sides of this inequality by 10. So that's what I'll do. I'll just multiply the left side by 10. And I'll multiply the right side by 10. Now remember, since I'm multiplying both sides of this inequality by 10, which is a positive number, I don't need to flip the inequality symbol. That's still the same. Okay, so now I could distribute the 10 to both sides, well, to both things right here. So the 10 here and the 10 here, right? So when I distribute the 10 to the first term, the 10 over 5 becomes 2, right? 10 over 5 becomes 2. So I'm going to have a coefficient of 2 sitting out front of the 2x minus 3. So I'm going to have 2 times the quantity 2x minus 3 for the first term, right? 10 over 5 is 2. There's the 2. There's the 2x minus 3. Boom. Don't forget to put parentheses around the 2x minus 3 because this is being multiplied by the whole thing. And then 10 times 2 is 20. Less than or equal to. And then here, 10 over 2 becomes 5, so this becomes 5x. So that's what I have now, which is really nice because I don't have to do the GCF. I'm fine there. You know, doing the GCF gets rid of the fraction, so I just have a nice linear inequality. From here, you could distribute the 2 to both sides, to this thing. So you're going to get 4x. 2 times 3 is 6. Plus 20, which is less than or equal to 5x. Minus 6 plus 20 is plus 14. So now subtract 4x from both sides. So I'm going to have 14 is less than or equal to. So 5x minus 4x is x. Right? So that's what I have. Now, I prefer to have x on the left side. That's just me. So if I want to write that way, I got to write it as x. Now the open part of the inequality is facing the x, so it has to be the same. All right, the open part of the inequality is facing the x, so the open part of the inequality still has to face the x here. Both of these are the same thing. All right, see how the open part is still facing the x? So the open part still has to face the x if I reverse the order of this. So this is my solution. So if I did that on a number line, if I graph that on a number line, and I put 14 on my number line, right? So that means that my interval is everything greater than 14. So that's everything over here, including the value 14 because it's equal to. So there's going to be a solid dot there. So as an interval notation, the smallest value on this interval is 14, and this goes out to the right forever, which means it goes out to positive infinity forever. And since 14 is part of the inequality, it's going to be a bracket at 14, and infinity never terminates, so that's always going to be open. Okay. I think I could squeeze letter B in here. Let me try it. So I have negative 9 is less than or equal to 2x plus 3 over negative 4. is less than or equal to 7. So this is a compound inequality, or a three-part inequality. So what you do to one side, or one part, you have to do to all three parts. Okay? Now again, I don't like fractions, right? So since I only have one fraction here, and not multiple fractions like the first problem, I could just get rid of it by multiplying all three sides by the denominator, which is -4. So let's do that. Okay, now I put some spaces here because what we did is we multiplied by a negative number. So remember, if you multiply or divide by a negative number in an inequality, the inequality symbol flips. So this less than or equal to becomes a greater than or equal to. This less than or equal to also becomes a greater than or equal to. They flip. Alright, so now, so -4 times -9 is +36, is greater than or equal to, so the -4 and the -4 here cancel, so I have 2x plus 3 in the middle, greater than or equal to, so 7 times -4 is -28. So this is what I have now. Alright, so, well, now that we flipped, since we flipped the inequalities here, this inequality is written in the incorrect order. There's nothing wrong with the inequality. It's just written in the incorrect order. Because we always, we traditionally write an inequality from least to greatest. So -28 is the smallest value, but that's on the right. 36 is on the left. That's the greatest value. So I want to reverse this inequality. I want to write it from left to right. I want to reverse the inequality's order here. So again, when you do this, we're going to put -28 on the left. And now, since the open part, or the point of the inequality, whatever side you want to look at. So since the open part of the inequality is facing the 2x plus 3, that still has to be true. Right? That still has to be true. The open part's facing the 2x plus 3. So the open part still has to face the 2x plus 3. Now on this part, the open part is facing the 36. So the open part has to face the 36. So this is the same part, this is the same inequality as that one, just written in the proper order. Now from here, it's pretty straightforward. Just solve for x. So subtract 3 from all three sides. Now since I'm subtracting 3, I don't have to flip the inequality. That only happens when I'm multiplying or dividing by a negative number. You could subtract 3 and still keep it fine. So -28 minus 3 is -31, which is less than or equal to 2x, which is less than or equal to 36 minus 3 is 33. Now the last thing to do is to divide by 2. Let me come up here. So I'm going to have x in the middle, right? And since I divided by 2, I don't have to flip this because that's a positive number. So I have -31 over 2 on the left, and I have 33 over 2. Those are fractions. They can't reduce. So just leave them as that. That's perfectly fine. Sometimes your answers are fractions. Welcome to mathematics. So if I draw this on a number line, right, this means x is caught between -31 over 2, which is -15.5, and -33 over 2, which is -24.5, I think. Let me use my calculator. Nope, 16.5. I couldn't be more wrong. Oh boy. So anyway, so just label these values on your number line and then graph the interval or shade the interval for those x values. So this means x is caught between negative 31/2 and 33/2. So that's everything in between. That's everything in between. And since I have equals underneath my inequalities, that means the endpoints are included in the interval. So they get solid dots. So the interval notation is going to be what? So the smallest value is negative 31/2, and that's included, so it gets a bracket, comma 33/2, and that's included, so it also gets a bracket. So those are my solutions, or that's the interval. My solutions are all the values in here, including these two endpoints. Okay. Letter C. Is 2 plus the absolute value of 2 minus 3x, absolute value less than or equal to 4. So again, so this is an absolute value inequality. So if you remember when we did this, we we have to isolate the absolute value before we do anything about the absolute value. So in order to isolate the absolute value, we need to subtract the 2 from both sides. And we get the absolute value of 2 minus 3x, which is less than or equal to 2. Okay, now if you recall from your notes, when we did absolute value inequalities, I think it was section 1.6, 1.7, I don't recall. It was one of the last sections of chapter 1. When we have a absolute value expression, right? So if you remember, if we have this, the absolute value of u is less than a, then the equivalent statement to that is u is less than a, but it's also greater than negative a. All right, if you look at your notes, something like this is in your notes. So we just need to make, and since we're dealing with an equal sign here, we could just put the equals there. So we just need to use this idea to write this like this. So u is just an expression, right? So my expression here is 2 minus 3x. So let me rewrite this as my expression, right? My expression is less than or equal to a, which here is going to be 2. But it's also going to be less than or equal to negative a, which here is going to be negative 2. So rewriting this like this is the same thing. And now we know how to solve this. This is a compound inequality. We just did that in letter B. So now from here, it's pretty familiar. Subtract 2 from all three sides. So negative 2 minus 2 is negative 4. Less than or equal to negative 3x, which is less than or equal to 2 minus 2 is 0. So now what we need to do is we need to divide by negative 3x. Uh-oh, what do we need to do? So since I divided by a negative number, I have to flip the inequality symbol. So negative 4 over negative 3 is 4/3. This less than or equal to becomes greater than or equal to x This less than or equal to also becomes greater than or equal to. 0 over negative 3 is 0. So again, this is fine, but it's written in the improper order, right? We should write an inequality from least to greatest. So let me rewrite this. So 0, I'm going to write on the left. And since the open part is pointing towards the x, the open part needs to point towards the x. And then the other side, so the open part's pointing to 4/3, so the open part must point to 4/3. That's better. This is the same as this, but this is written in the correct order. So that's my solution. So let's plot it. So this means x is everything between 0 and 4/3, which is like 1.3. So I'm going to label 0 and 4/3 on my number line, and then everything in between. And because 0 and 4/3 have equal signs under them, so they're both included in the interval. So in interval notation, the left-hand side, so the smallest value is 0, and it's included, so it's going to be a bracket, comma, 4/3, close bracket. And that's it. That's it. So again, remember this idea. It's in your notes, but that's what we're doing here. We're applying that idea to solve this inequality. Okay, what we're going to do now is we're going to look at number 4. So number 4 deals with the writing complex numbers in standard form. So letter A and B are pretty straightforward. It's just addition and subtraction. So how do I write this in standard form? Well, just distribute the negative. So I have negative 2 plus 4i. And now just combine the real and imaginary parts. So 6 minus, so the real parts are right here, right? And there's 6 and minus 2. That's the real part. And the imaginary parts are 3i and 4i. So 6 minus 2 is 4, and 3i plus 4i is 7i. And that's it. That's in A plus BI. That's in the standard form. Letter B. 4 times 3 minus I plus 3 times negative 5 plus 2i. So here we have to do a little distribution, and then it's pretty much the same. So distribute the 4 in the first group, so it's going to be 12 minus 4i plus, so distribute 3 in the second group, so 3 times negative 5 Oh, I got a little premature. I shouldn't have written that plus sign. So 3 times negative 5 is minus 15. And 3 times 2i is 6i. So 12, and so now it's the same thing as we did up here, right? Here's the real numbers. And here are the imaginary numbers. So the real part, 12 minus 15 is negative 3. Minus 4 plus 6 is plus 2i. That's in standard form. So, you know, those are pretty easy, if I'm being pretty honest. Letter C. So here we have a division problem, 3 over 3 plus I. So remember, when it comes to, when we did this in our notes, we have to simplify it. We want to write it in standard form, and in order to do that, we have to multiply the fraction by the conjugate over the conjugate of the denominator. So the conjugate of the denominator is 3 minus I. So we got to multiply this fraction by 3 minus I over 3 minus I. When we do that, so just multiply across the top and the bottom. So 3 times 3 minus I over 3 plus I times 3 minus I on the bottom. So let's do the top. So distribute the 3, you're going to get 9 minus 3i in the numerator. And then when you do this in a denominator, you're going to FOIL it. Right? You're going to FOIL this. So first outside, inside last. So 3 times 3 is 9. 3 times minus I is minus 3i. I times 3 is plus 3i. And I times negative I is negative I squared. Now, when you multiply a conjugate by itself, the middle term will always cancel out. Notice how the negative 3i and positive 3i, they cancel out. That always happens when you multiply a conjugate by itself. So there's the numerator. And then in the denominator I have 9 minus I squared. Alright, so now I have to simplify this further. So do not cancel the 9's out here. Don't do that. You cannot do that. You can't cancel these i's out either. You can't do that either because I have subtraction on top and bottom. And whenever you have subtraction or addition in a fraction, you cannot cancel them out because they're not factors. They're sums and differences. That's a very common mistake, and you cannot do that. So what I have to do here is I have to recognize that I have I squared here. Right? And if you remember in your notes, I squared is equal to negative 1. Right? So when I go through this, right, let me come down here. So I still have 9 minus 3i in the numerator, but now I could just replace I squared with negative 1. So I'll have 9 minus, because I have a minus sign here, times, I have 9 minus negative 1. Now from here, the denominator becomes 9 minus negative 1, which is 9 plus 1, which is 10. And now if I break this up, I could write it in the traditional standard form. So if I break that up, I could write that as 9/10 minus 3/10 I. And that is in standard form. All right, I have a number plus a number times I. A number plus or minus a number times I. The number could be a fraction, there's nothing wrong with that, but that's in standard form. Letter D. So this is a higher power of I you need to simplify, right? So a higher power of I, if you remember the way I did it, there are several ways you could do this problem, but the way I showed you how to do it is you want to divide 2 into 50, or you want to divide 2 into the numerator, and whatever remainder you have left over, you're going to tack it on as a multiple, okay? So I want to divide 2 into the numerator. Alright, so this just becomes a long division problem. So 2 divided by 50, or I'm sorry, 50 divided by 2. So 2 goes into 5 twice, right? So 5 minus 4 is 1, bring down the 0. So 2 goes into 10 5 times. 5 times 2 is 10. I don't have a remainder. So this means 2 goes into 50 25 times. It goes in evenly. So what I could do is I could rewrite I to the 50th. I could just rewrite this as I squared to the power that I got when I did the division, which is to the 25th power. And the reason why it's I squared is because I know what I squared is equal to. I squared is equal to -1. That's why I do this with 2, because I know what I squared is equal to. It's a very common power of I we work with, so I want to use it as much as I can. I know what I squared is equal to. I squared is equal to -1, so I could just replace this with -1 to the 25th power. -1 to the 25th power is what? Well, it's either going to be +1 or -1. 25 is an odd number. If I have an odd number, if I have something raised to an odd number, the result's going to be negative, right? If I have a negative number raised to a negative power, the result is going to be negative. So this is going to be -1. If I have a negative number raised to an even power, the result will be positive. That's it. Letter E. See if I can squeeze it down here. So this means I have 2 plus 3i to the 3rd power. Okay, so now when you're doing this one, you just got to multiply all 3 terms out. FOIL the first 2 and then distribute the second, or the third one. So I'm going to have 2 plus 3i times 2 plus 3i times 2 plus 3i. So FOIL these 2. FOIL them. Alright. The third one we'll just ignore for the time being. So when I FOIL this, I get, so 4 plus, what, that's going to be 6i plus another 6i plus 9i squared times 2 plus 3i. Let me simplify this down a little bit. 4 plus, so 6i and 6i gives you 12i, plus 9i squared, and that's going to be times the third factor of 2 plus 3i. Okay, now when I come up here, so now what I want to do, so it might be tempting to replace this I squared with -1. That might be tempting, but we're going to hold off on that. I want to distribute the 2 plus 3i to all three terms here. I want to hold off on that. I'll do the replacements later. So I'm just going to multiply the 2 by 4, 12i, and 9i squared, and then I'm going to multiply the 3i by the 4, 12i, and 9i squared. You're going to multiply each term in here by each term in here. That's all you're going to do. So you're going to get 6 terms when you're all done with this product. So 2 times each one of these, so let's write that out. So 2 times 4 is 8. 2 times 12i is plus 24i. 2 times 9i squared is 18i squared. Alright. Now 3i times 4 is 12i. 3i times 12i is going to be what? 36i squared. And then 30, I'm sorry, this is 3i. And then 3i times 9i squared is going to be 27i cubed. Alright. So now that I've did this distribution, I'm going to combine like terms. So here's my numbers. Well, I only have one number. Here's my I terms, so 24i, 12i. Here's my I squareds. And then I have an ugly I cubed there. So let's combine them. So I only have one number, which is 8. Let's combine the i's. So 24i and 12i is what? 36i. 18i squared, 36i squared is what? 18 plus 36 is 54i squared. And then I have plus 27i cubed. Alright, so now what I could do is I could replace, now that I did all this, now I could replace, so remember, I squared is -1, but what's I cubed equal to? So remember in your notes, I cubed is actually equal to -i. Right? It's just -i. So I can replace I squared. I can replace this I squared with -1. So I'll have 54 times -1. And then I can replace, so plus 27 times I cubed, which is -i. Alright, so what I'm going to have is 8 plus 36i minus 54, right? And I'm going to have minus 27i. So I have two more like terms to combine. Alright, so I have 8 and -54, and I have 36i, -27i. So when I combine them together, what do I get? Well, 8 minus 54 is what? -46. And 36 minus 27 is +9. I. That's in the standard form. That's it. So yeah, that was a lot of work. Now, let me come back here and make this recommendation. You could replace the I squared here with -1. You could do that here and make this a little bit easier. However, you want to be careful about doing that because sometimes that could lead to issues. That's why That's why I hold off until I do the product before I make the replacements for I squared and I cubed or whatever. So just be aware of that. Don't replace this with -1 just yet. Wait till you do the multiplication first. Wait till you get all the terms, combine all the like terms, and then replace them, and go from there. All right, so that is that's number 4. So let's look at number 5. So I give you the ordered pairs 1, -1, and -2, 3. My first question is find the distance between the points, round to 2 decimal places if needed. So you're given these ordered pairs, right? So the first question is to find the distance between the points. So remember, the distance formula is d equals the square root of y2 minus y1 squared plus x2 minus x1 squared. So if this is the ordered pair x1, y1, and this is the order pair x2, y2, right? Just replace them in this formula and do the computation. It's pretty easy. One of the first things we did in the course was this. So I'm going to have quantity, so y2 is 3 minus y1, which is -1. So be careful about the double negative here. And that quantity is squared. Plus, close quantity, so x2 is going to be -2 minus x of 1, which is 1, and that quantity is squared. All right. So just start from the inside, work your way up. So this quantity is 3 minus -1, which is 3 plus 1. All right, so that's 3 plus 1. 3 plus 1 is 4, so this becomes 4 squared. Plus, so -2 minus 1 is -3, so that becomes -3 squared. Four squared is 16. 3 squared is 9. Well, -3 squared is 9. So the square root of 16 plus 9 is 25. And the square root of 25 is 5. So there you go. That is that's the distance between those two ordered pairs. All right. Letter B. So find the midpoint. Well, the midpoint formula is easy, right? That's just the average between the x1 and x2 coordinates and the average of the y1 and y2 coordinates. That's the midpoint of the line segment joining these lines. All right, so if you made the equation of the line between these two ordered pairs, which you know how to do from Math 105, the midpoint, which is the center point, is found by this formula. So that's easy. So x1 plus x2, so that's the average of the x coordinates, so it's 1 plus -2, which is 1 minus 2 over 2, comma y1 plus y2, so that's -1 plus 3 all over 2. So if I go with that, so 1 minus 2 is negative half, comma, negative 1 plus 3 is 2 over 2. So my midpoint is negative 1 half, comma, 1. And that's it. All right. Number 6. So number 6 is a word problem. Number 6 is a word problem. So it's about, mixing two coffees together, two blends of coffee. All right. So what you could do here is you could set up a table, right? It's not totally necessary, but personally I like setting up tables. I think they're a very nice way of organizing your information. So in question 6, right, I might need more lines. I don't know. I'll just write what I need instead. Okay, so in the first question, I read the question. A coffee manufacturer wants to market a new blend of coffee that sells for $3.90 per pound by mixing two coffees together that sell for $2.75 and $5 per pound, respectively. What amounts of each coffee should be blended to obtain the desired mixture? All right, so this is a total value problem, right? I'm trying to find the total value of what I need. So the formula I'm using is, the total value formula. Which is measured in dollars. All right. So how do I get the total value? Well, you take the cost per pound, right? So that's dollars per pound, right? It's dollars per pound. That's the cost per pound. And the dollars, right? Or I'm sorry, the total amount, which is measured in pounds. So as you can see, this is going to work out, right? Cost per pound times pounds, you're going to left with dollars, right? If you look at the units, multiply them together, the pounds cancel, you're left with dollars. So I know that this is set up correctly because you take this and you multiply it by this to get this. So you take this, multiply it by this amount to get this amount. And I'm looking at the comparison between two different coffees, right? So I'll just, even though there's no names for the coffees, I'll just call it coffee number 1 and coffee number 2. And the total between them. All right, so now I just got to fill in my table from the information given. So what is the unknown here? Remember, the unknown is the first thing you want to do. The unknown value is the thing you want to label. So you want to let a variable represent the unknown. And it says what amounts of each coffee should be blended to obtain the desired mixture, right? Okay. So we want to let X be the amount of one of the coffees, either coffee 1 or coffee 2. I'll let X be the amount of coffee 1. So because I know that's the case, I'm going to put X there. All right. Now, the other coffee, so you know what, before we keep going, let's fill in the table with what we know. It'll help us with the problem. So coffee number 1, so if we read the first sentence, a coffee manufacturer wants to market a blend of coffee that sells for $3 per pound by mixing 2 coffees that sell for $2.75 and $5 per pound. All right, so when we mix together the coffee, right, the cost of the mixture is going to be $3.90. All right, that's the mixture cost. The cost of one of them is going to be $2.75. And the other one's going to be $5. All right. Okay. So, since I don't know the total amount, between the 2 coffees, I need to create another variable here for the other coffee. So I'm going to let y be the amount of coffee number 2. So I'll put that there. And now the mixture between them is just the sum, right? You're taking this one and adding it to that one. Right? That's the mixture between the 2. So now what I want to do is I want to find the total value equation. So I'm going to take this, times it by that to get 2.75x. 5 times y is going to be 5y, and that's going to equal 390 times the sum of x plus y. All right. So my equation is going to come from adding this amount plus this amount equals 3.90 times that amount. So let's just go through with this. So I have 2.75 x plus 5y equals, so let's distribute the 3.9. So I'm going to have 3.90x plus 3.90y. Let's combine like terms. So I'm going to subtract the 2.75 from here. Alright, and I'm going to subtract, well, it doesn't really matter. Doesn't really matter. and subtract the 5y. That gets rid of that. That gets rid of that. So I'm going to have .75 minus 3.9 is going to be negative 1.15x equals 3.9 minus 5 is going to be negative 1.1 y. Something doesn't make sense here. So what I have is, that's my equation from this. Just give me 1 second. I want to see what's going on here. Something doesn't make sense. This problem seems incomplete to me. Just give me some, just give me a little bit. I want to figure out what is going on here. I don't know why this isn't. I need to have another piece of information, and I don't know why. Oh. Well, yep. So, as it turns out, the problem I wrote down was incomplete. There's another piece of information that I didn't write down. So, this entry right here, even though technically, I'm sorry, this mixture is supposed to be 100 pounds total, which was another piece of information that this textbook, I swear. So this is supposed to be 100. In the problem it says, assume that the total weight of the desired blend is 100 pounds. So in this question right here, assume the total mixture is 100 pounds. But when I got the question, I got it from the wrong source because it's not the same. Of course not. So this entry, when we do the math, so that's going to be 3.9 times 100, which is 39. Or no, I'm sorry, 390. So, my bad, guys. So I'm going to have several equations here. All right, I'm actually going to have figures on this problem. That's the one piece of information I didn't get right. But that's what you get when you don't write the whole problem down. So you're actually going to have two equations because I have two unknowns. So the first equation is going to come from adding x plus y, and that equals 100. Right. And this equation is going to come from 2.75x plus 5y equals 390. Sorry about that. So now when I solve this equation, I could do this easily. Now I have enough information. I knew something didn't make sense because the way I wrote the problem, it didn't seem like I had enough information in it. But there was a piece of information that was missing, and I will make you aware of that when I send this video on Canvas. But now to solve this system, which is what it is a system of equations, I just want to solve one of the variables for x or y and substitute it into the other one. So let me so these are my equations, first of all. Now, the first equation I'll solve for y. So that's going to be 100 minus x. And then take that and plug it in here into the second equation. So when I do that, I'm going to get 2.75x plus 5 times the quantity, 100 minus x, equals 390. So now, 5 times 100 is 500, minus 5x, which equals 390. I can combine the x's together. So when you do that, you're going to get negative 2.25x plus 500 equals 390. Subtract 500 for both sides. So you're going to get 390 minus 500, which is negative 110. Divide by negative 2.25. That's going to be well, it's going to be approximately 48.9. Alright. So if x is 48.9, I'm going to take 100 from that. Right, so I could get y, right? So y was 100 minus x. So that's going to be 100 minus 48.9, which is roughly 51.1. So to answer the question, how much do I need of coffee number 1? I need X amount, which was 48.9 pounds. And coffee number 2, I needed Y amount, which is 51.1 pounds. Assuming I did my computation correct, which looks like I did. Alright, so that's the word problem. Again, I apologize for that. When I wrote this problem on your review sheet, I missed a little, there's a little hint. I literally took this problem from your textbook, and there was a little hint that I missed, but again, that's what the answer is. I apologize. That's what the answer is. And that's how you would get that. That's how you would get that answer. All right. So number 7. Is list the x and y intercepts and test for symmetry with respect to the x-axis, y-axis, and the origin for each equation. So we did this at the beginning of chapter 2. So y equals x to the 4th in letter A. Y equals x to the 4th minus 3x squared minus 4. So the x-intercept that means y is going to be equal to 0. Alright, so when I do that, I want to replace y with equal to 0. So I'm going to get x to the 4th minus 3x squared minus 4 equals 0. Alright, so that's what I want. That's the equation I want to figure out. Now I can't factor this equation. There's just no way I could solve this equation without using my calculator. I have to use my calculator here. I have to use my calculator because this is a 4th degree polynomial, and well, actually, now that I think about it, that might be quadratic in form. Now that I think about it. So yeah, actually, this is quadratic in form. So, I mean, as long as you show your work, like as long as you showed that you used your calculator to find this, or you did it by hand to show that you did it in quadratic in form, either one is acceptable, just as long as you could justify what you did. If you used your calculator and showed a picture of it and showed how you got the roots, I could actually see what you did. But if you did quadratic in form, you could do it that way as well. So it's quadratic in form because if I look at it, it's some number squared minus 3 times a number minus 4 equals 0. So what would I put here to make this x to the fourth? Well, I could just put x squared there. Right? X squared squared is x to the fourth, and this x squared is still x squared. So as you can see, it's quadratic in form. It's quadratic in form because it's we could let u be equal to x squared. So if I did this by hand, I would have u squared minus 3u minus 4 equals 0. Now this is quadratic. You know how to solve this. Let's try factoring it. U and u. The factors of 4 that give me 3 are 1 and 4. This is negative, so that means the greater of the two must be negative. And since this is negative, this one must be positive. So those are my factors. So this means u plus 1 equals 0, u minus 4 equals 0, which means u equals negative 1, or u equals 4. Now I can replace u with x squared. So that means x squared equals negative 1, and x squared equals 4. Now, if I solve these equations, well, if I solve this equation, actually, as it turns out, so if you take the square root of both sides here, right? If you take the square root of both sides, what you get on this equation is you get, oh, that's an imaginary number. And since we're not graphing with imaginary numbers, I don't care about this solution. Doesn't give me anything, because we're only concerned about real numbers when we're finding intercepts. So this equation, x squared equals negative 1, doesn't give me anything. But this equation, if I take the square root of both sides there, right, that's x equals plus or minus 2. So my x-intercepts are going to be 0, negative 2, and 0, 2. So you could do this by hand, or you could do it with your calculator. Either one is fine. If you use your calculator, you could write x to the fourth. Oop, that's the wrong one. Minus 3x squared minus 4. If I graph it, there's my graph. So as you can see, it only crosses the x-axis in 2 locations. They're going to probably be negative 2 and 2. Let's check it. Second, calc, 0. Left bound, that's good. Right bound, that's good. Hey, negative 2. And if you check, that one's 2 as well. So those are my x-intercepts. The y-intercept is easy. That's when x equals 0. You just will plug it in, right? So this becomes 0, this becomes 0. All you're left with is minus 4. 0 to the fourth minus 3 times 0 squared minus 4 is just equal to negative 4. That's it. That's easy. So that's going to be 0, negative 4. All right. We have our intercepts. So now let's test for symmetry. So x-axis symmetry So I'm going to replace y with negative y, right? So when I do that, I get negative y equals x to the fourth minus 3x squared minus 4. Do a little algebra, so multiply both sides by negative 1. And what you get is y equals negative x to the fourth plus 3x squared plus 4. That is not the same as the original equation. It's not the same. So we know it's not symmetric to the x-axis. Alright, let's do y-axis symmetry. So that means you replace x with negative x. So when you do that, you're going to get y equals negative x to the fourth minus 3 times negative x squared minus 4. So y equals, so negative x to the fourth power, so this is an even power, so the negative becomes positive. So it becomes x to the fourth minus 3 negative x squared, same thing. That's an even power, so the x becomes positive. Minus 4. This is the same as the original equation. Right? This is the original equation. So I'm symmetric to the y-axis. So there's no need to test for origin symmetry because I already know it's symmetric to the x-axis or the y-axis. And if you look at your graph, you can see it, right? You can see how it's symmetric to the y-axis. It's just a mirror image. You can flip it over. You can see that. All right. Letter B. So let's find the intercepts for letter B. So the x-intercept, that's when y equals 0. So when I have that, I have x cubed minus x equals 0. Now, at first you might be thinking, oh, I can't solve this by hand. Actually, you could. So factor out an x. So x squared minus 1 equals 0. Now you could factor this to be x plus 1, x minus 1, or you could just set each factor equal to 0. X equals 0, x minus 1 equals 0. So that's the first solution, and then this just means x squared equals 1, which means x equals plus or minus 1. So my x-intercepts are 0, 0, 0, negative 1, and 0, 1. The y-intercepts, that's when x equals 0, so just plug it in. 0 to the third power minus 0 is what? 0! And, you know, I could tell, right, because when we did the x-intercepts, we found out that one of them is the origin, 0, 0. So remember I said, if you have an origin as an intercept, it's both an x and y-intercept. So that makes sense, right? You don't have to see that going through the math, or, you know, just recognize it's the origin. So let's test for symmetry. So x-axis symmetry, replace y with negative y. So that's going to be negative y equals x cubed minus x. Do a little algebra. Multiply both sides by negative 1. and I get y equals negative x cubed plus x. That is not the same as the original equation. So let's try y. Axis symmetry. Replace x with negative x. Negative x to the third power minus negative x. So negative x to the third power, well, that's an odd power, so this negative is still stuck there. It's still negative x cubed. Minus a negative makes it a positive x. Now this is not the same as the original equation. It's not. Alright, so let's try origin symmetry. So that's when we replace both x and y with negative x and negative y. So when we do that, we get negative y equals negative x to the third power minus negative x. So if I do a little algebra here, all right, let me just keep the negative y here for a second. Let me simplify the x's. So again, negative x to the third power is negative x cubed minus negative x is positive x. Now let me multiply both sides by negative 1. So I'll get y equals what? Negative 1 times negative x cubed is positive x cubed. Negative 1 times x is negative x. Is that the same as the original equation? Yes, it is. So my equation is symmetric to the origin. So if I look at my graph, there it is. That's the graph of this equation. It's the graph of y equals x cubed minus x. So if I zoom in a little bit, you can see how it is symmetric. So what that means is you could fold it this way and then fold it that way, and you'll get that. You know, if I were to do this on paper, so if you look at it, right, part of the graph is here, right? It's doing that. So if I fold it this way first, I'm going to get something like this, right? And then if I fold it this way down with respect to the x-axis, or with respect, if I fold it this way, I'm going to get something that looks like this. And that is the graph I have. So that's what it means by symmetry to the origin. You just do them both. You just do both of them. Flip it against the y-axis, then flip it against the x-axis. And that is my graph. And that's why you could see it's symmetric. Okay, so here's what I'm going to do. That was question 7. I am going to omit question 8 from the review because I feel like, I don't know, I feel like we didn't get far enough that I would like to, so I'm not going to put that on the exam. The cutoff point will be 2.1. So I'll send an email to everybody to make sure of this typo that I had here and to omit question 8. So anything from 1 to 7 could be fair game for this exam. Okay? So yeah, that's the exam 1 review. This is that was part 2 of the exam review. So, yep, so that's the end of the video. So if you have any questions, you know how to get a hold of me.